let's talk through it. Donovan, let's make sure we write this down since you're missing this. McKay, I know that I had to push on your ideas a little bit, but what did we talk about? What example did we create for this do this section?
2 1/3 power 1/3 equals 3 or a cube root 2.
Notice we're letting the a be 2, right? Letting the n be 3. So what we're trying to show is that 2 raised to the 1/3 is in fact the same thing as the cube root of 2. So what do we do from there, McKay?
The inverse of the root.
What is the inverse of a cube root?
Cube.
So a cubed. Can I do that just one side? No? So I also have to do it to this side? So, Moen, when I raise a power to a power, what do we do? Okay.
Don't you divide it?
What do y'all think? Do we divide our powers when we raise a power to a power? You're saying no. Okay, Mona, can you look again for one that looks like this, where it's a to the m raised to the n? You see that example?
Yeah.
What does it say then?
You're talking about number 2, right?
I think it's number 2.
Okay, say it equals a m over n.
Not?
I mean, my bad. A over m n.
Okay, a raised to the mn, which means m and n are being what? What's the relationship between m and n? What operation is there? Moan, if you had 3x, what's the operation between the 3 and the x? Are they being added?
Multiply.
Are they being multiplied, right? That's the operation. So what's happening between m and n?
Well, I guess they didn't multiply it.
The only mathematical operation that you don't have to show when there's variables involved is that multiplication. If it was anything else, we would have to show the addition, show the subtraction, show the division, but they're being multiplied, right? So when we raise a power to another power, we're multiplying those exponents, right? So 2 to the 1/3 times 3. And when I cube a cube root, what's going to happen there?
Cancels it out.
Why do they cancel out?
They're the same.
Not the same.
They're inverses.
There we go. They're very opposite of being the same. They are inverses of each other, which cancel each other out. The cube and the cube root cancel. And then now I simplify this exponent.
1.
What is 3 divided by 3? So that's 2 is equal to 2. Is that a true statement?
Yes.
So notice how using the same inverse, these came out to be the same. So that rational exponent must be the same as the cube root. The rational exponent of 1/3 had to be the same as a cube root. Does that make sense? And Linnea, we did something similar on 2.6, and that's where you were looking, right? We were looking at the 12th root of 1.05, and we said that that is the same thing as 1.05 raised to the 1/12. That's what we saw in 2.6. And so you didn't quite write it this way because we didn't do that yesterday, but what could I do here to show that the 12th root and raising it to the 1/12 are effectively the same?
Raise the 12.
What's the inverse of a 12th root? The 12th power. Once again, 12th power, 12th root, they will cancel their inverses, so 1.05. And Mona, what do I do when I raise a power to a power? I multiply them. Huh?
Cancel it out.
Well, they will end up canceling them out because it's 1/12 times 12, and what's 12 divided by 12?
1.
And so 1.05 is equal to 1.05. Right? And a very basic premise, and this is very, not basic, generic premise, a to the 1 divided by n equaling the nth root of a. What power would I apply to this generic expression? Any ideas?